Hi, this is Physics 2212, and you're watching Lab 2 Charge Tape Revisited with Sam Jabley. So an introduction before we get started. In this lab, a model of the experiment from the previous Lab 1 will be created where the charge tape is divided into multiple lines of charge. The purpose of this lab is to compare the electric force from the model in the previous lab, the point charge model, to this new model, the lines of charge model. The lab is going to showcase the principles of Newton's second law, Coulomb's law, and the law of gravitational force as the previous lab did. So some details and results preview. The system is the tape that has its two ends resting on the two objects a distance apart. The tape on top, that's the system. The surroundings is the tape below and everything else. The experimental model is the physical experiment from last lab, and the computational model will be created using GlowScript. And a little results preview. Each tape's charge was calculated as 2.33 times 10 to the negative 9th power coulombs in the point charge model, and 1.04 times 10 to the negative 8 coulombs in the lines of charge model. So, same fundamental physics principles from the last lab. You've got Newton's second, a system's change in momentum divided by change in time is equal to its net force. You've got Coulomb's law, which describes the calculated electrostatic force between two charged particles at rest. And you've got the gravitational force, which describes the force of mutual attraction between two objects with mass. And the Lab 1 results for a quick callback. You have the experimental model, and here's all the initial conditions and data from that lab. And here's the computational model that gave the tape's charge and the force. And you have Lab 2 calculations here. And you have the same initial conditions and data from Lab 1. And over here you have the calculations. And you did the gravitational force by just doing mass times gravitational acceleration. And you have the electric force, which is the same as the gravitational force in magnitude because the tape on top is staying still. And here I have calculated the electric charge using E-rod, because when you cut up the tape into little pieces, it looks like a rod and behaves like a rod. And you solve for Q using force is equal to QE. And so now the computational model. Coulomb's constant and gravity are already given here. The mass of the tape on the charge and the charge on each tape that was calculated are inserted down here. And the length of the tape and the distance between two tapes is also inserted down here. And this is the constant section. And so now here you have the electric field function that I created. And basically I inputted R, Rmag, and R hat and used that in the formula for the electric field. And down here is a function already given, and basically it just creates the lines of charge. So here I edited the top tape and bottom tape position vectors and the n, which is the number of segments, and I changed that to 40. And I changed the arrow scale here and also here. And I changed the code to calculate the electric force on the top due to the bottom and the arrow for the net electric field at the top due to the bottom. And then I edited the axis on the electric force and gravitational force arrows here. So let's look at the results of the computational model. So the blue tape is the bottom tape, the red tape is the top, and they're pretty close together, but they are a distance apart. And you can see the arrows from the electric force from the bottom tape pushing the top tape up, and those are these green arrows. And down here you can see the magnitude of the electric force and the magnitude of the gravitational force displayed. So, some assumptions and errors. Air resistance and friction are assumed negligible, and I assume that the same amount of charge is on the same each piece of tape, or that the same amount of charge is the same on each piece of tape, and that each piece of tape has an equal amount of evenly distributed charge. And the errors, unequal distribution of charges in reality means that there will be different answers from computational methods. Loss of charge to the surroundings, of course, and the measurement of values such as distance and length being off by slight amounts. So, quick discussion. What if each piece of tape was modeled as a point charge, and how does this compare to the line charge model? Well, here are the two right here, and you can make that comparison. The line charge is a much bigger number. Why do the estimates of electric charge in each model differ, and which is closer to the actual value? Well, they're different from one another because different methods of calculation were used, and as well as possible errors adding up, One method, the line charge method, is more precise than the other method, the point charge method. And that is why the line charge model is more accurate, as it finds the charge of the tape as small segments that can account for the length of the tape rather than just a single point on the tape. Thank you very much for watching. I hope you learned something, and I'll see you next time.